Hope you're doing alright out there. Today we're going to be taking a close look at the dwarf planet Ceres and trying to understand the origin of the surface of Ceres and its craters. Ceres is a dwarf planet located in the asteroid belt, and it's actually said to be a young body because the surface doesn't have that many craters as to be presumed an old body. That would be using impact craters to determine the surface of the age of the surface by counting the craters and determining how many craters hit a surface over a given period of time. My honest opinion of that idea is I think that's ridiculous. I guess before I came across EU, I would have been skeptical of that hypothesis. The EU actually led me to be able to think of any possible way that these craters would just form suddenly. So we're going to be taking a close look at electrical formations in silica to try and gain some understanding as to, are these actually electrical cratering on the surface of Ceres. And I can guarantee you with certainty from looking at the craters myself that most of the craters on Ceres are indeed formed electrically, and there's not a doubt in my mind. I can look very closely at these craters. The images are tough to get with my video camera, and the fine silicas will, even after the first experiment, will sometimes start to block the shots. But I think I've found a way to sort of get across that and capture some of these features on film a little bit, and definitely some of the main features that can be seen and recognized by looking at images on Ceres. So this is about as close as I can get, and so without further ado, I'm going to start trying to draw some of these formations out. So when the discharge is occurring, there's usually several filaments. I guess there would be three, but mainly I guess two are going at once. They just kind of are moving around, and so they create sort of a triangle. I think that's what creates some of the straight line edges, is that the Birkeland current and the twisting or whatever is causing that to happen. Then there's also, sometimes you'll see the current will be going like this, like two small craters far apart, but then and one will be like this, and then a very large one forms. So you have the rimmed crater feature, and sometimes there's even a shot where one filament seems to sort of like travel, and it could have potentially formed something like this with two craters. Then at the very end there's a straight lined rimmed crater, which is pretty intense. Then this is the hardest feature for me to draw, but it's sort of like I guess you could call it a scalloped ridge or something. But this is the main one, unfortunately, that I need for y'all to look at. I guess it looks something like this. It almost will produce these like weird diamond ridges or something, and then there's like another scallop, and it keeps going, and I guess they're shaded. It's really tough for me to draw. It'll be like some sort of weird wavy lines or whatever inside of the crater ridges, and that's actually what we're going to be like you want to look the most closely at is the shadows that are formed on the crater ridge, because that, I believe, is one of the dead tail signs that the craters are formed electrically. Sort of a scalloped ridge has a sort of a wave as it goes down and tapers off. And of course, some of the craters are straight lined. The rotating, which forms dual craters, rimmed craters, and sometimes even fractal rimmed craters, where it can go like that because the filament is moving so much throughout the discharge. And that's another main feature, is that all these images can be seen throughout the entire discharge, and they don't just happen all at any point. The discharge can stop and look like any one of these features, essentially, and that's the predictive power of the electric hypothesis. Now, after looking closely at those, if you've come to the determination that the craters are indeed formed electrically, I mean, you just gotta ask yourself, where did these craters come from? Because the asteroid belt where Ceres originates would seemingly be the largest source for crater impacts in the solar system. So there's this huge dilemma where you have an asteroid belt that was likely formed as a result of some sort of electrical activity, and it's presumed that the asteroid belt is, I don't know, in my mind, just phantasmally appears in a nebula from a star exploding, then colliding upon itself and creating itself. It's absolutely ridiculous when you look and consider that it was likely formed electrically. There wasn't that many impacts happening afterwards, just like there aren't nowadays. I guess that's the way it is. Just as it's been going on, I don't know. It's hard to tell. So I guess the main point is that the astrogeological picture that's been designed for our solar system is clearly flawed. And this can also be seen in the discovery of Saturn's water connection to Earth in its rings. So it's I guess it's up to people to discover the truth themselves and to paint a picture. And